If no one wanna speak up, so I generalize everyone can do already, okay? So now I go with so complex number, but today we're going to discuss complex number in polar form. So usually in the previous discussion, you have z equals to a plus bi. So if in polar form, the z is written as r times cos alpha plus I times sine alpha. So the polar form is this one, the second one. So how can we change the first expression to the second expression? So for example, I have a complex number, like z is equals to 2 plus I. So if I ask you to plot onto an Argand diagram, so remember this is the I, this is the action. So it means if you plot it, it's 2I, which means you find a 2 right here, and you find 1 right. So let's call this line that I draw as R. How do you find R? Square root of what? If I say square root of 5, you understand? So it's a square root of x squared plus y squared. So for the y, we only take the coefficient of I. I repeat it. For the y, we only take the coefficient of I. So we got root 5 there. Now, if you refer to the right angle triangle, so this is root 5. This is your angle. Then when I want to solve the adjacent side, I should start with cos alpha, which is equals to adjacent over root 5 over r in this case. So it means my adjacent side is equals to r times cos. So it means if I want to find the opposite side, I won't be using cos, but I will be using sine. So it becomes r times sine. So your complex number at the first place is z equals to a plus bi. And your a is on the x-axis because it's a real part. So the x-axis in this case is r cos alpha. And the b is the y, the imaginary one, the opposite side, which is r sine alpha. And there's an I there. So I can take out the R. So it's leaving cos alpha plus I times sine alpha. That's how I got the expression from. Any questions until here? No. Now we continue. How do you find alpha? So tangent alpha. So the opposite side is 1 unit. The adjacent side is 2 units here. So tangent alpha is 1 over 2. Then you can shift tangent, but make your calculator mode in radian mode. So shift tangent 0.5. So it gives you 0.46 radian. So it means that z is equals to square root 5 times cos 0.46 plus I times sine 0.46. Any questions until expressing in a polar form? Like what is the 0.46 or 0.5? Any question? No. So everyone understand R is from where? Okay. Can I take picture of the screen? alpha in this case is being called as argument of z. So if I use the term argument means the angle. Yeah. So in complex number, there's a rule for the angle only can lies in between negative pi and the inclusive sign is at positive pi. So meaning, let's say now I want to change question number 2, the z is negative 2 minus I. So if I plot it, is it still in the first quadrant? No. So it's at the third quadrant. Does the value of r change? No, r doesn't change. R still root 5. The angle that you have found just now, this angle, also 0.46. But you cannot read counterclockwise, because if you read counterclockwise, you go beyond pi. You go more than pi, not allowed. So how do you write the answer for the angle? For the angle, you have to take the clockwise. So means what is the alpha that you write? You should take negative because you go clockwise, right? So basically like A mat still. So pi minus 0.46. So negative because you go clockwise. So the angle is 3.14 minus 0.46. So you have negative 2.68 radian. So means the answer for this should be written as square root 5 cos, the angle is negative 2.68 plus I times sine negative 2.68. So if cos negative, the negative can be ignored, right? If sine negative, the negative can be taken out. Yeah? Any question?
So how can you know at third quadrant?
Because the x is negative and the y is negative.
So, for example, the range is until 2 pi, you can take the angle directly or need to do others.
Yeah, the angle have to be another way around.
So the other way around.
Okay, the angle rule have to be between negative pi to pi. So if at the fourth quadrant, you have to read clockwise. All have questions can take which of the screen. Done, right?
Yeah.
So when you learn this complex number, there are some part that you have to learn. Maybe some of you have learned, some of you haven't learned. But then there is one discussion about trigonometry that I think most of you never learned. This one, if you expand, is the same with cos alpha times cos beta minus sine alpha times sine beta. So if plus, it will become minus. That is the rule. So if minus, it will become plus. So cos, sine, sine. But if sine, right? So this one plus minus, this one minus plus, yeah. So it's another way around. If sine, if I expand it, it will become sine alpha cos beta, sine cos, sine. So let's say sine 75, you can change to 30 plus 45, right? So you can apply that. Now, what is the point of changing the complex number to polar form? So the exercise that you have done before is very easy. It's just like -1 plus 2i to the power of 2. So if I make it to the power of 10, let's say still using the same equation. Let's say I make it like 2 plus I to the power of 10. The question is, how much effort are you going to put in solving power of 10? So we want to avoid a very long working. Like I want to get the answer for the power of 10 in a shorter way. So to solve it in a shorter way, you need the polar form. You need the polar form. Before I show you how the polar form apply, the first two is a trigonometry rule that you should know. So if you don't know, then you can take note of it. Now, let's say I have two complex numbers. So the first complex number, the angle is alpha. Then the second complex number, the angle is beta. Then let's say I solve z1 times z2. So it means the r1 and r2 I can multiply first, right? Then leaving what in bracket? Leaving the cos plus sine and cos plus sine, right? So if you expand the bracket, you understand to do expansion, right? Like cos alpha, you times cos beta. Beta cos alpha, you times with sine beta. You know, expansion, right? So if you expand it, you get cos alpha times cos beta. Then you have plus I times sine alpha times sine beta. And now I move to the I sine. So I sine times cos beta, it give me I times sine alpha times cos beta. And last is I sine alpha times I sine beta. So you get I square. I square means -1. -1 sine alpha times sine beta. Any of you have questions until here?
So can you repeat again?
Expand the cos alpha. So means you should have two brackets. Cos plus I sine and cos plus I sine. So one is alpha, one is beta. You expand them. So you arrive at the right writing.
Okay, sir.
Any of you have questions again? No, we can take a picture of this. So now the result, just now z1 times z2. I have solved until r1 times r2, right? And then you pay attention at the picture that you have taken. If you have the picture, you know, there are two terms that don't have I, which is cos alpha, cos beta, minus sine alpha, sine beta. From the picture that you have taken, there are two terms that don't have I, which is cos alpha, cos beta, minus sine alpha, sine beta. You can find that? You can find that, you refer to the first row, also at the same picture. When you have cos minus sine, it come from what? Cos minus sine is coming from cos alpha plus beta. So if I say cos alpha plus beta in the first row of the trigonometry I introduced you, if you expand it, what will it give you? It will give you cos alpha cos beta minus sin alpha sin beta, right? So cos alpha cos beta minus sin alpha sin beta could be written as cos alpha plus beta. Then you can find two terms which have I. What are the two terms that have I? I sin alpha cos beta plus I sin beta cos alpha. Take out the I. So what's left? You have sin times cos plus what? Sin times cos plus cos times what? Sin. You can apply the second row on the trigonometry equation, which is equals to sin alpha plus beta. So if I write sin alpha plus beta, if you expand it, what will it give you? The second equation becomes sin alpha cos beta plus cos alpha sin beta, an equation. It is not easy, but it's learnable. So it depends on how much you want to learn. If no, you also will waste your time if you follow this class.
So can you repeat just now?
Your two terms that don't have I on it, the two terms are cos cos minus sin sin. So if cos cos minus sin sin, right, if you group them together, it will become cos open bracket alpha plus beta. So when I write cos open bracket alpha plus beta, if you expand it and you use the first equation that I give you, it become cos alpha cos beta minus sin alpha sin beta.
Okay, sir.
So if the one that have I, you factorize the I, is leaving sin times cos plus cos times sin. So if sin times cos and cos times sin, it will become sin open bracket alpha plus beta. Others? Okay. No question. So what is the point? The point that I derived this long formula is I need to show you. If you multiply two complex number, it's as simple as multiplying the R and adding the angle. If you multiply two complex number that you have changed to a polar form, the result is as simple as multiplying the R and add the angle. So back to the questions. So the question that you are going to solve the z is 2 plus I to the power of 10. He asks you to solve that, right? You go back to 2 plus I first. When you have a 2 plus I, what is the R? How do you write 2 plus I in polar form? Square root 5 times what? Cos 0.46, right? Plus what? I times what? Sin 0.46. So when I say power of 10, meaning how many times will you do the multiplication? 10 times. So means your root 5 is mean later 2 plus I to the power of 10. The root 5 you multiply with root 5, right, for 10 times. So become root 5 to the power of 1. That's what I mean R1 times R2. So it's as simple as multiplying the R. So you multiply the R, which is root 5, for 10 times. So become root 5 to the power of 10. Any questions until there? Then it's as simple as adding all of the angle. So you add each of the angle, which is 0.46, for how many times? Also 10 times. So it will give you cos 4.6 now, right? Plus 1.
Sir, the 0.646 from where?
0.46 just now at the first place, at the first question, I have 2 plus I, right? I use the tangent to solve the alpha.
Okay, sir. The previous question on this.
Yeah.
Okay,
4.6, right, breaks the rule already, because the rule that I tell you must lie in between negative pi to positive pi, if you pay attention just now. So 4.6 break the rule. Where is 4.6? You take 4.6 minus 3.14 first. So you get 1.46 at here. So this is actually 4.6 until here. So are you allowed to write 4.6 is go beyond pi? Not allowed. So which one you should take the answer as? You should go clockwise. So the clockwise one is it? So negative 1.68. So you should change your 4.6 later, become negative 1.68 at the final answer. So the answer is 5 to the power of 5 times cos negative 1.68 plus I times sine negative 1.68. Any question?
Sir. Sir.
Yeah.
Can repeat again? I don't understand, sir. The 4.6 minus. The 4.6 minus 3.14. Why?
4.6, you get it because it's 0.46 times 10, right? So it's 4.6. And once you get 4.6 ready, you should place it in. So 4.6 is at which quadrant? You have to place it. If at second quadrant, then up to 3.14 already. If at second quadrant, you need up to 3.14. So you just 4.6 minus 3.14. My point is at the third quadrant. But if at the third quadrant, it has broken the rule, so you cannot take it as a positive value. You should read a negative value. Any others have questions again? No? You can take a picture of this screen.
Sir,
Yeah.
just now I disconnected. I don't know how the 0.46 become 4.6.
The angle 10 times. Should add the angle 10 times because the power is 10.
The left side also have to do the same thing.
Yeah, both of the angle 0.46 plus 0.46.
Okay.
So let's say W is equals to Z to the power of 5. So how am I going to solve it? You have to pay attention here. You see the cos and the sine, there's a negative sign in there. So we have to fix it first. Fix it as in like, if you pay attention when I teach just now, I told you it's coming from a negative angle. You know the angle have to be the same, right? Inside the cos and the sine. Right? So actually the original version is like this. Right? So just now I did mention like the negative one can be ignored right, for cosine. And for the sine, the negative can be taken out, right? Become minus. Anyone have questions until here? No. So what is the point of changing it back? So when you say W is equals to Z to the power of 5, means the R, you power it by 5, right? So we become root 3 to the power of 5. What you do to the angle? You add it with himself for how many times? 5 times. So I suggest you, if you're going to add the angle, you should keep it back as a plus sign. So if you have a negative sign, just put a negative. Then you can apply the one that I teach you just now. So if negative 1.5, does it break the rule? It doesn't break the rule because still in between negative pi to positive pi. Anyone have questions until here?
Sir, why the cos have negative also?
The angle have to be the same for both. So it cannot like cos is positive, sine is negative, cannot. So if the sine one you put it, if the sine you keep the negative in, right? This the cos also you have to put a negative in, have to put it back again.
So if have negative in the middle, so both need to have
Both of them
negative.
negative. Yeah, that's the point that I want to explain to you. No question. Okay, you can take picture of the screen. Then we'll continue again. So if the rule is if it's division, which means you just divide the r, and then for the angle, it will become a subtraction. Any questions you want to ask until here? If no, I will send the questions I want you to do. Exercise 17B, number 6 and 7.